Hello friends. Welcome to Science and Tech. If you not subscribed our channel yet, then please subscribe it and then also click on bell icon. Let's start. Today I am going to tell you about the sun is sneezing solar storms towards Earth. Right now, the sun is stirring up violent eruptions capable of wiping out the technology we are so dependent on, and new research has found that these blasts are even harder to predict than scientists first thought. The findings reveal that these coronal mass ejections hurl into Earth's atmosphere like a sneeze rather than a stream of bubble-like structures. The cloud-like eruptions are also strongly influenced by the solar wind, forcing researchers to reconstruct their space weather forecasting. Up until now, it has been assumed coronal mass ejections move like bubbles through space, and respond to forces as single objects, said Matthew Owens, lead author from the University of Reading. We have found they are more like an expanding dust cloud or sneeze, made up of individual plasma parcels all doing their own thing. Speeding through the solar system at up to 2,000 kilometers a second, 1,200 miles, coronal mass ejections are powerful outbursts of magnetic flux and charged gas that erupt from active spots on the sun's surface. These things reach Earth within 1 to 3 days and can occur every few hours when solar activity is at its peak. They are a driving force of extreme space weather, triggering geomagnetic storms that can fry power grids, communication networks and expose astronauts to cancer-causing radiation. If that isn't scary enough, a previous study by the same team predicts that a mid-century plummet in the sun's magnetic activity will make Earth even more vulnerable to these violent solar events. With this in mind, we need to prepare ourselves ahead of time to survive the disruption. But even though coronal mass ejections happen so frequently, scientists still struggle to predict when these supersonic eruptions will slam the Earth's atmosphere. And according to the new findings, it looks like we've had it all wrong when it comes to understanding how these things work. When tracking coronal mass ejections, scientists have assumed that they take on an organized, bubble-like structure. But after taking a closer look at how they move through space, the researchers found that coronal mass ejections expand and become more chaotic as they approach Earth. For the first time, the team took a detailed look at how coronal mass ejections travel through space and interact with the solar wind. Examining a cross-section of one of these solar eruptions, the researchers discovered that the plasma parcels expand faster than the speed of information inside the structure. This indicates that only part of the coronal mass ejection is affected by the outside forces it's interacting with, rather than the whole. The weakening of these expanding magnetic forces results in a disorganized cloud-like structure resembling a sneeze rather than a blow of bubbles. Additionally, these eruptions are more closely linked to the solar wind than previously thought, making them even harder to track ahead of time. This means that trying to predict the shape and movement of coronal mass ejections as they pass through the solar wind becomes extremely difficult, said Owens. Therefore, if we want to protect ourselves from solar eruptions, we need to understand more about the solar wind. Now that we have a clearer idea of how coronal mass ejections work, let's hope that we can find a better way of predicting when the sun is about to sneeze all over Earth. Thanks for watching. Please subscribe for more interesting videos.